Hello, everybody. My name is Georgios Vulgaris, and I'm going to present our work in deep learning robustness to domain shifts during seasonal variations. As you can see on the image, when classifying land use from satellite images in geographic locations, such as Southeast Asia, spurious correlations can arise if the training or test data is taken at a single time of a year, because there can be quite extreme changes in flora between wet and dry seasons. As you can see on the image, when the classifier is trained using wet season data, it can associate agriculture or barren land classes with green color features that are dominant in the wet season images due to abundant flora. This has the result that the model will be biased towards wet images and will not generalize well when predicting images from the dry season where the flora is scarce, resulting in the brown colors we see on the images. Our work aims to reduce the sensitivity of the training process to spurious correlations arising from data from different seasons. How we're going to do that is by biasing a model to focus on relevant background features by replacing the first layer of a standard 5-layer convolutional network with a Gabor feature prior. And B, since the predominant spurious attribute between seasons is color, we compare a normal 5-convolutional layer network with a Gabor CNN in a mixed dry-wet season dataset and assess how much removing color information affects their performance before testing how models perform if trained tested on wet dry season images only and vice versa. So here we can see on the image an example of analyse net filters, and we can see that convolutional filters are often learned redundantly, and some filters, as we can see here, compared to the Gabor filters on the top right-hand side, are very similar. There are similarities, as you can see with a highlighted yellow. So that means Gabor filters is very efficient in extracting texture features, thus biasing the model to focus less on color and more in texture. So our paper contributions are first that we show that when applied to the mixed season data, Gabor CNN is a little less affected by removing color and focuses on more salient features in the images compared to CNN5. Second, we saw that removing color gives better generalization between dry-wet season domain shifts. And finally, we saw that we will see that Gabor convolutional neural networks trained with grayscale images has the best generalization between dry-wet season domain shifts and again focuses on salient image features. So on the first part, we use a mixed season dataset comprised of 13,177 images of 9 classes, and each image is size of 256 times 256 pixels, and the spatial resolution of 0.6 meters per pixel. So here we can see that the Gabor CNN classifier is less biased towards color as expected and relies more on texture. So by using as an example the most confident misclassified images and use the class activation mapping, we see how the difference between the two classifiers. So in the first image, we see that the human annotator has classified it as agriculture, even though the majority of the image is comprised of a forest. The Gabor CNN focuses on heavily on the trees and predicts correctly that it's forest, while the CNN5 focuses on the agriculture area and predicts urban green spaces. On the second image, it's classified as urban, and you can see that the majority of the images are buildings, and on the front, on the bottom, there is a parking. Gabor CNN focuses strongly on the buildings and correctly predicts that's urban, while the CNN5 focuses on the parking and predicts urban. The third image is been classified by the human annotator as urban, but you can see that the dominant feature is the roads. The Gabor CNN focuses on the roads, as you can see here, and predicts roads, while the CNN5 focuses on part of the land and predicts roads. Finally, on the fourth image, we have an industry complex where the Gabor CNN focuses heavily on the industrial building and predicts correctly industry, while the CNN5 focuses on the road and the barren land on the top to predict industry. So we can see that the Gabor CNN architecture seems to focus on more salient image features and is more resilient to the removal of color information. It is possible that it would be more resistant to extreme domain shifts, such as the difference between dry and wet seasons. To test this, the two classifiers were trained using wet season data and predicted dry season data and vice versa. So we used two data sets for that. One is comprised of wet images of 8,574 images, and the other data set is comprised of dry images and there are 5,338 and 8 classes. Here we can see that there appears to be a greater resilience of the Gabor CNN when trained on the grayscale images, and believe that this is because the feature bias focuses the model on more salient image features. By using class activation map, we will show how the feature bias affect the model predictions of wet season data when trained on dry season by shifting the focus to different parts of the image. So as you can see, on the first image, we have it's been classified by the human annotator as agriculture, while most of the image is a forest. So on the color image, Gabor CNN heavily focuses on the trees and predicts forest, while on the grayscale images focuses on the agriculture and predicts agriculture. CNN5, on the other hand, focuses a little bit on the trees and classifies it as agriculture, and then the grayscale focuses a little bit on the trees on the side and predicts forest. In the second row, labeled as barren land, we again see that Gabor CNN trained without color focuses more strongly on the correct features than the other models. So while it classifies it as agriculture here, this is expected as the classifier is trained on dry season data, and agricultural land during that season resembles the barren land. Both Gabor CNN with color here and CNN5 on grayscale images focus on the trees, but we classified the images as industry, as agriculture, respectively. Finally, when trained with color, CNN5 does focus on the part of the barren land, though not as strongly as you can see as the Gabor CNN, and misclassifies the image as industry. The final image is brick kilns, and again, Gabor CNN with the grayscale images focuses strongly on the actual building and predicts it as brick kilns correctly, while on the color images, it focuses on the texture of the trees and predicts forest orchard. CNN5, on the other hand, on the color image, while it focuses on the brick kiln, it predicts wrongfully industry, and on the grayscale, it focuses on the land surrounding the brick kiln and predicts agriculture. So, to conclude, we showed that floral transformations between wet and dry seasons cause variations in satellite images, which can significantly affect classification performance in the presence of domain shift. Second, when trained on mixed season data, removing color information does not impact classification performance significantly. Furthermore, when trained on dry season and tested on wet or vice versa, there is a large drop in performance. By using the Gabor CNN, architecture with grayscale images, we can ameliorate some of the issues of domain shift from seasonal data while retaining strong performance on the mixed data set. Finally, we saw that by examining class activation map images, it appears that introducing feature bias through the Gabor layer results in focusing on more relevant image parts compared to CNN5 architecture, highlighting the benefits of carefully consideration of initial feature priors. Questions?